A $15 million missile challenging a $13 billion aircraft carrier is now one of the most talked about contrasts in modern maritime strategy. China's newest long-range systems are designed to influence how close large vessels can operate across the Pacific. In this video, we break down how these precision missiles work and what this cost imbalance means for the future of strategic mobility, regional stability, and the balance of naval power worldwide. The global debate around China's missile program largely begins with one remarkable comparison. A precision system priced around $15 million is now being discussed as a potential challenge to one of the most expensive assets in modern military history, a $13 billion aircraft carrier. This contrast is not just financial. It reflects a shift in strategic thinking about how nations may influence mobility across the world's oceans. China's most referenced systems are the DF-21D, DF-26, and DF-17, each representing a different stage of range, response time, and technology design. The DF-21D was among the first medium-range ballistic systems specifically designed to target large surface vessels. With a reach estimated between 1,500 and 2,000 kilometers, it was initially highlighted for its demonstrated ability, under controlled conditions, to approach a ship-sized target. Although these early demonstrations took place in a limited testing environment, they showcased significant improvement in guidance technology. The DF-26 extends this capability much further. Its approximate 4,000-kilometer range allows it to influence areas far deeper into the Pacific region. Analysts often highlight its adaptability because it can switch between different precision mission profiles. This adaptability suggests a broader strategic purpose: to create a system that operates effectively in changing environments without requiring extensive modifications. Meanwhile, the DF-17 introduces an entirely different layer of technological advancement by incorporating a hypersonic glide vehicle. These vehicles travel at extreme speeds while maintaining the ability to shift direction mid-flight. This maneuvering creates a more complex path, making prediction and interception more difficult. Reports of its accuracy against stationary targets have contributed to its reputation as a major step forward in precision strike development. However, engaging a moving maritime platform adds new challenges because the target changes location constantly. All of these systems share a key theme: shaping the environment rather than matching large vessels directly. Carriers require years to construct and billions of dollars in investment. In contrast, missiles can be produced at a lower cost and in larger numbers, creating a strategic equation where quantity and mobility challenge size and financial weight. While the price comparison is striking, the central question is much more technical. Can a long-range missile consistently track and reach a moving vessel across a constantly shifting environment? This challenge forms the foundation of China's approach and is rooted in a complex network of sensors, data links, and real-time surveillance tools. The process begins with satellites. Over the past decade, China has expanded its space-based tracking capabilities, launching optical, radar, and electronic intelligence satellites designed to monitor large areas of ocean. These systems offer broad awareness, but satellites follow fixed orbits. That means they only pass over specific regions at certain times. During the intervals between passes, the position of a fast-moving vessel may change significantly. Even with rapid updates, the ocean is vast, and ships are deliberately unpredictable. Land-based over-the-horizon radar adds another layer. These systems bounce signals along the upper atmosphere to detect distant objects far beyond traditional radar limits. They are effective for identifying the presence of large platforms, but they lack the pinpoint accuracy needed for precision guidance. They can detect that a large object is present in a general area, but cannot reliably provide the exact coordinates required for a high-speed guidance system. Airborne platforms provide more detail. Long-range patrol aircraft and unmanned reconnaissance drones can observe surface movement more closely, but they must fly over or near open water to do so. These assets face environmental challenges, range limitations, and potential countermeasures intended to disrupt or obscure their readings. Their task is to refine the data collected from wider-range sensors and create a clearer, more accurate picture of the target's movement. Even with initial tracking data, a long-range missile may require updates during its flight. A carrier traveling at high speed will not remain where it was first observed. To maintain accuracy, mid-course corrections must be transmitted through secure, uninterrupted data channels. Any interference, whether environmental or electronic, could create inaccuracies in the missile's final trajectory. The most complex stage occurs near the end of the mission, known as the terminal phase. Sensors must remain functional, guidance must adjust smoothly, and the vessel must still be in the predicted location. While China advances its long-range precision systems, the United States is reshaping how its carrier groups operate. Aircraft carriers remain key strategic platforms, but their protection now relies on multiple defensive layers, enhanced mobility, and a shift toward more flexible operational patterns. The first defensive layer consists of guided missile destroyers and cruisers that travel alongside the carrier. These ships deploy multiple types of interceptors designed to engage different kinds of incoming systems at varying distances and altitudes. By layering these defenses, the group reduces the chance of relying on any single protection method. This networked approach means carriers operate as part of a larger ecosystem rather than as isolated vessels. Electronic support capabilities form another critical component. Specialized aircraft such as the EA-18G Growler are designed to disrupt tracking and guidance tools used by opposing forces. Their purpose is to limit the clarity of surveillance systems and complicate targeting accuracy. Additionally, ships employ decoys and electromagnetic tools that distort radar images or create signature variations. These measures encourage incoming guidance systems to misinterpret the carrier's position or chase misleading signals. Operational flexibility is also evolving. The U.S. Navy is shifting toward a distributed model of operations. This involves spreading influence across submarines, surface ships, unmanned platforms, and aircraft, reducing the predictability of carrier movements. Longer-range tools, such as carrier-launched refueling drones, allow air wings to operate farther from the carrier itself, enabling the main vessel to remain at greater distances while still supporting regional activity. Research and modernization efforts continue to reinforce this approach. Development of advanced radar processing, more accurate tracking tools, and emerging technologies like directed energy systems contribute to updated defensive architecture. These innovations signal that the U.S. does not intend to rely solely on traditional defenses, but is continually incorporating next-generation solutions. The overall strategy emphasizes adaptability. Even as long-range systems grow more advanced, carriers remain relevant because their support network evolves to match new challenges. China's $15 million precision systems and America's $13 billion carriers highlight a dramatic contrast, but effectiveness depends on far more than cost. Tracking accuracy, defensive architecture, and continuous adaptation shape the future of maritime operations. As both nations innovate, long-range precision and flexible carrier strategies will define the next era of ocean mobility. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Also, you can visit our website, spaceinews.com. Thank you for watching, and see you next time.